It's 1:52 a.m. Jordan is 19, surrounded by highlighted textbooks and empty energy drink cans, 3 hours from a biochemistry final she's been dreading for weeks. She's read the same paragraph about enzyme kinetics 4 times. Each time it feels new, like she's never seen it before. She checks the clock, feels a spike of panic, and starts again from the top of the page. By sunrise, she'll have studied for 11 straight hours. By the time she sits down for the exam, much of it will be gone. She did everything that felt like effort. Effort wasn't the problem. The all-nighter is treated like a rite of passage, proof of how much someone cares about an exam. But the advice culture around cramming almost never mentions what's happening inside the brain while it's happening. Studying and remembering aren't the same process. One happens while you're awake, taking information in. The other happens largely while you're asleep, when the brain decides what to keep. Students pulling all-nighters are maximizing the first process while eliminating the second one entirely, which means a night of cramming can leave someone with less usable memory than a shorter study session followed by real sleep. When new information enters the brain, it first lands in the hippocampus, a seahorse-shaped structure that acts like short-term holding storage. A memory in this raw form is fragile, easily overwritten, easily lost. It becomes durable, transferable to longer-term storage in the cortex through a process called consolidation. And a large body of sleep research has established that consolidation depends heavily on sleep itself, particularly deep, slow-wave sleep and REM sleep. Matthew Walker, a sleep researcher formerly at Harvard Medical School and now at the University of California, Berkeley, has run some of the most cited studies on this process. His research has shown that sleep after learning doesn't just passively protect memories, it actively strengthens them, replaying and reorganizing the day's information during specific sleep stages. In one widely cited study from his lab, participants who slept after learning a set of information retained significantly more of it than participants who stayed awake for a comparable period, even when total study time was matched. Sleep deprivation doesn't just fail to help memory, it actively interferes with the hippocampus's ability to take in new information in the first place. A study led by Walker and colleagues, published in Nature Neuroscience, used brain imaging to show that sleep-deprived participants had measurably reduced hippocampal activity while trying to encode new memories compared to well-rested participants even before any question of retention came up. In plain terms, the sleep-deprived brain isn't just bad at remembering later, it's worse at learning in the moment. Caffeine and energy drinks, a near universal feature of all-nighters, complicate this further. Caffeine blocks adenosine receptors in the brain, adenosine being the chemical that builds up through the day and creates the pressure to sleep. This creates a feeling of alertness without addressing the underlying sleep debt. Research on stimulant use during sleep deprivation, including studies reviewed by sleep scientists at Walter Reed Army Institute of Research, has found that caffeine can mask the subjective feeling of impairment, while cognitive performance, including memory formation, continues to decline underneath it. Students often feel more capable during an all-nighter than they actually are. There's a common assumption that pulling an all-nighter is at least better than not studying the extra material at all, that some exposure, even sleep-deprived exposure, has to help more than none. Or the research complicates this, because sleep deprivation impairs both encoding and consolidation. Some sleep researchers have found that performance on recall and problem-solving tasks after a night of no sleep can drop to a level comparable with material never studied in the first place. The information was technically read, but never properly stored. For subjects requiring reasoning, application, or connecting concepts,